So no one is recording, correct?
No one is recording.
All right. Okay. iPhone. Okay, iPhone, can you turn your camera on, please? And we will get started. Oh, thanks, Muriel. iPhone. It's on your end because everybody else can. You might want to click out and come back in again. That's up to you. All right, so talk to me about enzymes or ask questions about enzymes, either one.
Okay. Let's see if I this is on my phone. Okay.
Talk about enzymes.
Oh, I hate for you to have to do all the work, Muriel. You do seem to do work.
Well, so enzymes, aren't they the
Go ahead.
catalysts?
Yes.
Yeah.
Aren't they protein?
Yes.
Mhm.
Okay, they are proteins, they are catalysts. And you definitely need to remember that. I might add that, you know, they're used in reactions and they either facilitate reactions or they lower the threshold necessary for a reaction to be able to occur. So maybe they wouldn't occur without the enzyme. Maybe it would take a lot longer. Does
Mhm.
anybody have questions about that?
No.
They are proteins.
They're proteins. They accelerated all the reactions, right? Which is the metabolism, which is composed by anabolic reaction and catabolic reaction, which is the breakdown. I don't think I have any other questions. Are you? I know that there are like different types of inhibitions and also substrate. You're gonna come to that part, or
Those are perhaps a deeper level
Mhm.
than what we need right now.
Okay.
We might need them in the future. If you're going to go for a master's, you might need that information.
Okay, I think it's a power tools temperature, each an amount of functions.
I'm sorry, I couldn't understand. There's a sketchy connection.
Sorry, I'm
here,
in the
so-
car. So, yeah.
That's all right.
Sorry.
Just the connection, no worries. Okay, so let's talk about a eukaryotic cell. What do you know about eukaryotic cells?
So eukaryotic cells, they are cells that has inbound organelles, which is mitochondria, Golgi apparatus, you know, and the plasma reticulum, I think.
Endoplasmic reticulum is the way that's pronounced.
Mm-hmm. And then, so those are all inbound organelles, which means they have a layer around them.
Wonderful. And what about respiration in that eukaryotic cell or glycolysis? Where would those occur?
So they occur in the mitochondria, and
Glycolysis is in the mitochondria, right?
yes, it is. Yeah,
I'm
it is one of the
gonna say
Wait, the cytoplasm
different
has
steps. Respiration happens in steps, and the
glycolysis in
steps of-
cytoplasm, right?
yes, ma'am.
Yeah, and the
Yes.
mitochondria, okay.
Yes, and you want to know that. So respiration is going to occur in different parts of the cell, and the glycolysis specifically, like you said, Janie, it's going to occur in the cytoplasm. It looks good, Dejanay. Yummy. I ate on the way home. Have you ever had to drive through Phoenix or tried to drive through Phoenix eating chicken wings?
No.
Not from the chickens in my backyard. No. Oh, all right. So thank you for that, both of you. Thank you. Fermentation, what does it do? What's the benefit of fermentation?
It releases something, doesn't it?
Oh, what
The
would that?
ATP or no?
Oh,
Energy?
yeah.
Energy? Oh, yay, okay.
Uh-huh. And what is ATP for us?
Energy.
Energy, right. And just to be a little bit quirky, where's the energy in the ATP? I already told Muriel before, and he might have already known.
Mitochondria. Oh, wait.
In the ATP.
Oh,
In the bonds?
It is. It's the bond between the
Wow.
second and third phosphate through ATP. Adenosine triphosphate, those three phosphates. And the energies between the second and third. So when it snaps apart, the energy is released, it's used, and then everything's recycled. Yeah. So what did the fermentation create again?
ATP.
Yes.
It is the process of fermentation, and then it breaks the bounds. That's why it happens. All the bubbles, because there's all the reactions between, acid and base,
yes.
So they release the.
Yes. Okay. Absolutely.
so fermentation creates ATP, and the ATP lies with the bond of the adrenal triphosphate?
It's energy.
Right.
It is between the second and third phosphate.
Okay, wait, it creates energy.
Yeah,
which-
yeah, it creates
the-
energy. It creates ATP.
Okay, okay.
Yep.
And it lies in between, the ATP lies in between that bond, what Muriel
The
said.
ATP is an adenosine here, and then three
Adenosine.
phosphates here. And the
Okay.
three phosphates, adenosine triphosphate, and the energies between two of these phosphates. And that was just to be a little bit quirky, okay? That's a deeper level than we need to go. It's like a
Oh.
Muriel answer.
Ah,
Oh, and we're grateful and thankful for him. Okay, fermentation enzymes. Talk to me about the classifications of enzymes. We have competitive enzymes and regulated enzymes. I'm sorry, I'm not supposed to be leading. You're supposed to ask questions about them, please.
So the enzymes, we have the non-competitive and the competitive if they are inhibitors. If they're not inhibitors, they're gonna bond with the substrate, right? But if it is a inhibitor, we have two types, which is a competitive and non-competitive. The competitive, they're going to resemble the form of the substrate, and then they're gonna bond to the location where the substrate would. But
right, they're going to compete.
Yeah,
for
they're
that
going to
position.
compete to that location, to the active site. So,
Mhm.
and then the substrate won't be able to fit in there and make the reaction to happen. And then the
Okay.
non-competitive, it is allocated in a different part of the enzyme, which is called allosteric. And then once that binds to the allosteric site, it occurs as like it's a deformation in an enzyme. So the original place where the substrate would have fit, it won't fit anymore because it changes our shape.
Okay, wonderful. Can you then, or anyone else, talk to me about regulated enzymes?
I don't know that.
They can be turned on or turned off,
And how
like
come?
induced or repressed.
Because of what will be the conditions, or why will that happen?
I don't know.
It's somewhat logical.
Professor Muriel, step in,
Oh,
please.
I don't know. It says regulatory. It has to do anything with non-competitive inhibition.
Well, what Janie said was right, and they're only made when they're needed. That's why they're made, is when they're needed, but then if they're not needed, then it stops.
Oh, okay.
And so that's called regulated. Does anybody have questions about that? Or, all right,
Is it the body who makes them?
the same as every other time.
Okay.
Yes. Yep. If you're talking about some things the body needs, but these, the body's making them. Yes. We'll talk about that other stuff another time. So if we're talking about bacteria, why? You all mentioned that in the mitochondria, was that where? We mentioned mitochondria and we threw that out the window.
ATP.
We talked about the glycolysis in the cytoplasm. But we know that the mitochondria are the powerhouses of the cells, of all kinds of cells, because this makes power. How does it get energy? Just loosely, not
How does the
It-
bacteria get energy?
in the mitochondria.
In
How
the
is
mitochondria?
energy
Okay.
created?
Good question.
I think I remember you mentioned that. I don't know if it's that or not though. It is by the releasing of gas carbonic, right, during the reaction, or not really. When I don't know.
The pyruvate,
Yeah, that's what I remember too. For the
Mm.
the Krebs
that's-
cycle.
Yeah.
Mhm.
Okay. So what are we creating in that? How are we creating energy?
We're using glucose, and then through glycolysis we start breaking it, and then it start becoming different substances, and then once it
Yes.
goes through the Krebs cycle, it starts breaking even more, and then we have coenzymes and all those things.
Okay, so in all of that big process, are we creating ATP? Yes. Does it have anything to do with harvesting electrons or something wonky like that?
Yes, no,
No,
it doesn't.
no.
No, it has something to do with
No.
the electron transport, which happens in the membrane of the mitochondria, but I don't think that's what you want to hear.
In other places, electrons are electricity, they're energy. But in the
Mhm.
mitochondria, we're making ATP, we're making glycolysis. We're going to end up with some pyruvate, like Maria mentioned. We're making actual molecules, okay, for energy. Is that okay? Does that make sense?
Okay, now I'm a little confused. I wrote down glycolysis is the first stage. It takes place in the cytoplasm. The enzyme splits a molecule.
Oh. Glycolysis, there will be 500 videos on how glycolysis
The
happens.
molecules pyruvate released into
I would-
energy transferred to ATP.
Go to Boozman Science or Khan Academy or one of those that's credible. What we're
Is
doing
Krebs
is,
cycle, but isn't Krebs cycle after glycolysis?
it's all going on very, very fast all the
Okay.
time. All of it's going on at all the time. And we want to remember that glycolysis is occurring in the cytoplasm. And where the Krebs cycle goes, where the electron transport chain, different,
In
okay,
the mitochondria happens.
okay, and that's what you were going to talk about, but we are not, we need to remember, we are not getting energy by harvesting electrons in there, okay? Just, we want to remember it's not to harvest electrons, we're still gaining ATP.
Okay.
And that's the main. And I already asked about enzymes, and Muriel, you explained competitive and non-competitive inhibition. And if you want to just briefly, if you don't mind, you could just tell everybody the difference between those.
Okay. So the enzymes has the active site, which is a normal substrate would bind to that location, and then would break right into two molecules. That's a non-competitive. No, so that's a regular enzyme activity. You have the active site, so the substrate lands on it, it fits perfectly, and which is known as a lock and key of something, and then it breaks the molecule into two molecules, right?
Okay.
And then we have the inhibition process, which is guided by two types, which is competitive and non-competitive. So the competitive, it is another molecule that resembles or remembers this, reminds the same formation or shape of the substrate. So it's going to go inside of the active site first, so the substrate cannot go in there. And that's competitive because you use the same location, which is the active site. And then the non-competitive, it is a molecule that binds in a different location in the enzyme, which called the allosteric site. And then once it binds in there, the active site, which is on top or whatever it is, it changes the shape. So the regular substrate, it does not fit in there. So that's a non-competitive because it doesn't matter. It doesn't matter. The allosteric site would be attached to a non-inhibitor, a non-competitive substrate, and then would change the shape of the enzyme.
Absolutely. So competitive, these are competing for the same site. Competitive is competing for the same site. Okay. Blocked directly at the site, and that's going to be competitive, just like Muriel just said. And non-competitive is the other type where it attaches the other place, and now the original site is altered. Okay. Does that make sense? Okay. Okay. All right.
Can I ask something? Because I just want to make sure I'm understanding the terminology and I'm in the right path. In the mitochondria, you had asked, so how do we think it makes ATP or energy? Is that right?
It's going to make it through the regular channels, and it's close to master's level. as
so we
far
don't
as
need to
in
know,
depth
like,
to go through, okay, you're going to get so many carbons, you're going to get pyruvate, you're going to do this around the Krebs
No.
cycle or the citric acid cycle, whichever way you say it, and then we're going to have the electron transport chain out this way. It's
No.
just, I used to have a wall on one of my classrooms that I made with beads and dowels and hot glue with the whole, but we don't need all of those molecular steps. It
do
won't.
we just need to know it takes food and oxygen and makes energy, nutrient?
Well, that might be even a little bit deeper than we need by saying, oh, it takes food. It does. It does.
Like
And
carbohydrate?
teaching this in nutrition class is fun. But what we need to remember is glycolysis is happening in the cytoplasm,
Okay,
and it's generating. And then it's also happening in we're making energy also in the mitochondria.
okay.
And
okay.
that's perfect. Let me go. And we want to remember that in the mitochondria, we're getting ATP. We are not gathering electrons.
Electrons, yeah.
No, that's different story somewhere else in a different class. Is that full enough? Okay.
Sounds better than the other one.
Okay. Well,
The other was like, what the heck?
I have a hard time with the really super. I mean, you remember all these details and then, yeah. Competitive inhibitions. They're competing for the site. What's competing? Enzymes are competing right at the active site. And then non-competitive, just like Muriel said, something else is coming under here and it's going to attach. Oh, and the site doesn't work anymore. It's not working. The enzyme activity is just blocked. Okay. Directly up here, indirectly down here, to use the same position that Muriel did. Okay, so let's talk about something else, which does have to do with atoms. Okay. What type? I can't ask that maybe. Talk to me about oxidases, reductases. Probably enough, those two.
They are enzymes because they have the A's in the end of the word.
Uh-huh.
Oh,
And
I
we
remember that.
are talking about atoms now, so
Mm-hmm.
you know that oxidation is oh crud, that's a bad word for it, but
Aren't we letting go of the electrons and then
yes, ma'am, that's exactly
Yeah.
what it is.
read the other one with the R, we are gaining electrons?
Exactly.
Thank you.
I don't remember what that R was
So
though.
Janie, explain the reductase. So explain what an oxidases are and reductases are, just exactly like you just now did.
Oxidases is release electrons. And then the R, what is that again?
Reductases.
Reducting is the opposite, where it gains electrons.
Is it not? Yeah.
Yeah.
So I remember seeing this from this class, of course, but also I remember from the chemistry class that we had the same thing. And then one way to think about it is the reductase. It comes from the root word of reduct, right? Which is you're gonna decrease or go to a negative potential or something like that.
Yeah.
So what that means is the electron has a negative charge.
Yep.
right? So if it's accepting all this negative charge, it's like numbers. After zero, if you go to the negative side, you're gonna be you're gonna be negative, and
Right.
then that means reduct, which is mean less,
Reduction.
which means reductase. So just remember, I know it's easy for me to remember that. I know it's only
is.
one way to think about it.
It is. It's a good way. Yeah, because every electron brings its negativity. It's lowering of the charge. Right.
Mm-hmm.
Right. Okay. So I have a super easy one and then a complicated one. Tell me what ATP is made of.
Is that the easy one?
Yep. Just the molecule.
It is I don't know how
Adenosine
to say it.
triphosphate, or that's
Yeah.
ADP. No,
Yeah.
that's ADP, right? No,
No,
that's right.
you're right.
Adenosine triphosphate, because ATP would be, no, ADP would be diphosphate, something like that.
Yeah. So so it is a molecule of what does it say?
Adenosine.
Adenosine and 3 molecules of phosphate.
Triphosphate.
Yes. Yes. Absolutely. And Desjardins, what would adenosine diphosphate be made? How would that be put together?
ADP. So it'll be the molecule and then two
Right.
what though? Because I don't know.
Phosphates. One
Phosphate.
adenosine and
okay,
2
never mind.
phosphates.
Okay.
Adenosine diphosphate, adenosine triphosphate.
Okay.
Yeah. Okay. We're going to go to, thankfully you had this in chemistry. Huh? The Krebs cycle. What does it make? It's going to make a lot of things. And you want to remember all of them. Might be easier to remember what it does not, but what does the Krebs cycle or the citric acid cycle, what does it produce?
Well, pyruvate, right?
No.
Oh no, pyruvate, it is the thing that needs to go in the Krebs cycle. So that's not. It is the 2 coenzymes NDA and FDA. I think that's what you're looking for. I don't know. Is it? Because
No.
because it's gonna be those who's gonna carry the electron through the electron transport.
Okay.
phase. Is that?
Okay, so it is going to produce FADH2. I'm getting noddings of the heads. You guys know this. I'm so glad.
Mm-hmm.
FADH2. It's also going to produce CO2.
Oh, I remember. Yeah.
And it's going to
Okay.
produce ATP.
Mm-hmm.
And it's going to produce NADH.
NAD, FDH2, I think. No?
Water. FADH2
Oh, water.
and water. Yeah.
Okay.
And water usually looks like H2O.
Yes. Often
Do
they
we
do.
have to know, how many FADH produces?
No.
So I think, no, okay.
That's a lot of
It is.
memorization that a lot of classes require, and we are not. We do not. Are you going to find pyruvate as a product of the Krebs cycle?
No.
No.
That's what it needs to get inside of the mitochondria.
Okay.
Kind of.
Are you going to find O2 as a product?
No.
Correct. So we really talked about 5 things that it does produce.
5.
5.
Oh, and water, right? You said. So is
Uh-huh.
it gas carbonic, ATP, NADH, FADH2, and water.
Uh-huh.
Okay.
The first one you said was CO2 or carbon dioxide.
Yeah, carbon dioxide.
Okay,
Mhm.
just making sure, because we can't make mistakes tonight. So. Talk to me about photosynthesis.
Energy from the sunlight and with oxygen.
Tell me again, Janie.
It creates, from the sun and the oxygen, it creates energy.
And what form is that energy in?
Cellulose. Is that it?
Tell me
Okay.
again.
Cellulose?
Plants?
That's the
Is that when it
fiber.
creates food? Sorry.
Tell me again, Dejane, I missed it.
When the plants create their own food,
Uh-huh, and their food might be glucose, yeah?
and then that's
So-
what, yeah.
Glucose and oxygen, but the oxygen might be for us. Products of
Mhm.
photosynthesis.
What is phototrophs?
I don't know.
I don't know too.
So a good thing to know is that
Troughs.
a photosynthesis is energy that's created from sunlight,
Energy and what?
sugar, glucose,
Well, right, and
oxygen.
O2,
yes,
yeah.
and oxygen. Okay,
Well, I think the sunlight and the oxygen create the glucose so the plants can eat, right?
right. And the
Okay.
plant gives off oxygen. I'm just gonna be a pain just tonight. Don't forget the oxygen with that glucose. Okay. Questions so far?
Glucose. No.
Do you guys mind just running over that, the ATP and ADP? There's 3 phosphates in the ATP.
Because tri is 3 like a tricycle.
Right. What else do I need to know though about that?
Nothing, you don't need to
Oh,
know
that's
that.
it?
You don't
Oh,
even
okay.
need to know that, but,
Oh.
but we talk about much more than what we need to know.
Okay.
And then I repeat things. All right. We have completed going everything that through everything I think we need to. Do you have something to add?
Are you able to like briefly, I guess, go over it again, just because I was a little bit late because I thought we were on the other app.
I surely can, and I apologize for that. I tried repeatedly, maybe 6 times, and the link would break and it said it was, I could try to make it work and it would not. So my apologies.
That's fine.
What do we call, let's start at the very beginning.
Mhm.
Musical. What do we use for catalysts? Catalysts,
Enzymes.
lists of cats. What was that, Janie?
Yeah.
Enzymes.
Enzymes. Okay. What are they usually, or what are they made out of?
Protein.
Is there anything?
Is it
else?
cholesterol? No, that's never mind. That's steroids. Never mind.
Ooh, they're made out of protein also. Which is why we never want to go on a low protein diet. All right.
Everything about our body is protein.
Pretty much, but my
Everything.
brain is at least
Everything.
half fat.
Oh, the brain is?
At least half fat.
Oh. Oh.
It's
That's why you
amazing.
need your healthy fats.
Yeah. Yeah.
Is
Okay,
that
so we don't need to
Joanna?
know about adenosine triphosphate with the nitrogen base and carbon and sugar. How many? No? Okay, bye.
Yes, you do.
Okay, so nitrogen base has 5 carbon sugar, right?
Wait.
And 3 phosphate.
Talk to me. Where are you? Talk to
Oh,
me
did it?
about.
It was just my notes.
Okay, right. And all the notes you took, you need. Are you talking about what the Krebs cycle creates?
No, it's the I know it's just like the adenosine triphosphate. What makes that up?
Oh,
It's a
yeah,
nitrogen
yeah.
base, it has
It's
5
fine.
carbon.
Yeah, it's a
Okay.
adenosine with 3 phosphates hanging on it,
Yes,
or adenosine and
okay.
2 phosphates. And that's okay. It's
Okay,
not critical to remember right now. So if you're writing a song about all this tonight to remember it, don't put that in. The song will be too long. Where does respiration, no, where does glycolysis happen?
At the cytosol, in the cytosol.
Cytoplasm, yes.
Yeah.
Cytoplasm. That's, yeah, one step. Okay. What does fermentation do?
It
Creates alcohol.
Which is, besides sugar on steroids, it is energy.
Oh,
releases energy
It is energy.
okay.
and alcohol.
Well, there's an alcohol that even if you have a really rotten immune system, it's doesn't have crud in it. It's just distilled so many times. It's kind of pure. I don't know if it's bourbon or what.
Hmm.
I don't remember. All right. Fermentation does create that energy. Talk to me about regulated or constitutive or competitive enzymes.
So the competitive ones are gonna be the ones that go for the active site. The non-competitive ones go for the allosteric sites, which is anywhere else other than the active site.
And they still function to block it. Right. So
They're also not affected by something.
which enzymes are only produced when we need them?
Regulatory.
Regulated, yes.
Regulated.
The same. You are correct. You are correct. When the mitochondria is making energy, what kind of energy is it making?
ATP,
Yes,
adenosine triphosphate.
right. Does that have anything to do with electrons?
No.
No.
None, nothing to do with electrons right there. Because we're in the mitochondria and we're trying to break glucose into pieces and get energy out of it.
And you said mitochondria creates ATP or ADP?
T as in
It's ATP, but it's from
Oh.
glucose and it has nothing to do with electrons.
Okay.
It's from glucose. So we've talked a few times about competitive and non-competitive inhibition. Do you want to review that, the short version, anyone?
What was it?
Competitive and non-competitive inhibition.
I'll try it. Let's see, non-competitive. Enzyme competitive inhibition. It resembles the substrate which occupies the active site presenting substrate binding. So preventing anything else to bind to it, the enzymes can't.
If it's the same site, then that's going to be competitive.
Yeah,
Okay,
enzyme non-competitive of 2 binding sites, active or regulatory. So there's 2 different sites it can attach to.
yeah,
Okay, thank you.
right. Okay. Was that enough?
Yeah.
Okay. All right. So,
I thought I missed more than what I actually did. So. I pretty much only missed the first question.
all right. Yeah, we went kind of slow considering.
Just what are the catalysts made of? What was that one?
A catalyst is an enzyme. That's an excellent question. Enzymes are used as catalysts, and a catalyst helps something to happen. Either something that couldn't happen or something that would take a lot of energy or work or time, and the enzyme helps it as a catalyst would to be able to happen, and maybe easier, shorter, faster. Yeah.
Are you also referring to the Krebs cycle, maybe? The 5 things
different
that
story.
it's made of? Oh yeah, I
Oh
didn't know.
no, do you want to tell me that?
I
Do you
didn't know
want
if
me
that
to
was her
tell me those
question.
5? No, she's
Okay.
talking about catalysts and
Oh,
enzymes.
so I'm sorry, I have one more question. So
I'm glad.
the catalyst, is that when so our enzyme, let's say, would be lactase, and the catalyst would be what, the lactose? Is that what you mean by that?
ASE is an enzyme, OSE will be a sugar. The ending of the word.
Right. So
Sucrose
for
is a sugar
lactose
that
would be the sugar, because that's the actual milk. So to, digest that, we would need the lactase, right?
yes.
So is that the catalyst? Is that what we're talking
Yes,
about?
that is the
Okay,
enzyme.
okay,
That's
I
the
get it.
catalyst or the enzyme. Yes.
Okay, thank you.
It's- oh, that's cool. Thank you. And that's made out of protein.
Okay.
Yeah. Anybody have questions?
Do you have like a list of vocabulary words that you want us to study for the test?
Would you like Carolina for me to post the video?
A video? This video?
This one, uh-huh.
Oh,
This
I'm
one.
taking notes. I have a lot
Okay.
of notes. I'm good.
Okay.
Yeah. Just wondering if
Okay.
there was like something else.
Dejanay, what'd you say?
I would like it posted,
Okay, okay.
please.
And that would be easier than going through and writing the list of words. If I were to make a list, Carolina, what I would give to you is FADH2, CO2, ATP, NADH, and H2O, water. And what are those products of?
The Krebs cycle.
Yeah. That's the list I would give you if I were to give you a list of words.
Okay, well, thank you guys. I have to go, but thank you. Good
Have
night.
a good night.
You too.
I'll post it for you, Dejanay, later.
Okay, thank you.
Anybody have questions?
I have a question. So is this the review for midterms or for the
Oh,
test?
no, we haven't even thought about midterms so far, but I will do my best. With midterms, do you have recommendation?
Just a review. That's
Can
it.
we do it in the class, you think, or no?
Yeah.
It depends on if people are interested in that or not. I did a little bit of that. Was it 2 weeks ago in lab? Just asked a few questions. What do you all think? Because I don't want to stir up the pot and accidentally do a bingo or a Jeopardy.
Well, we have the printout from Canvas of what to study and what to know. What if we all, I mean, I don't know if it's too much, I'm not a teacher because I don't want everybody talking at once. What if we all just kind of like do it together, like pick a question and I don't know. No, not good.
It
Makes
would be,
sense.
it would be good. You would learn a lot. It might raise your points a couple percent. Me, I'm game for learning more than I'm game for getting points, but I know you have to get the points too. Does that make sense?
Mm-hmm.
We have to do both. I would rather you all be able to work together and study together with it. And I don't know, I think maybe that's the advantage of the Kahoot is people can see each other's icon at least.
Sounds good.
There, what sounds good? I didn't get the idea.
Well, I mean, I guess we can maybe discuss it in class, but if we read off of the review that we have and you can intervene if we're on the wrong path or something. I don't know, because sometimes when Muriel says something, I'm like, oh yeah, okay, that's how I can remember it. And then Joanna, like the other day, she said cowgirl. And I was like, oh, that is great. I like that actually better than what I could remember. So that's all I was kind of
Yeah.
saying.
Right. Okay. That sounds good to me. I don't know what everybody else thinks and how that would be best orchestrated.
Maybe it's nice to have another Zoom meeting like this.
Tell me again, I've been trying to find out how to bring you guys in because I don't have pages. Those of you without cameras on are not showing because I accidentally clicked something at the beginning. There you are.
Maybe Zoom meeting is also nice like this.
We
I
can
don't know
do
for
that.
other ones, but
We can do that. What are you all comfortable with? We can use class time. We can use Zoom time. We can do it through Jeopardy games where everybody can discuss at the same time on your team. Or, you know, every Jeopardy question is a multiple choice question. Every bingo question is a fill in the blank, which you do. It's not this class fill in the blank though.
I didn't want to make it bigger than it was, so I guess we can just ponder and talk about it tomorrow.
Will everyone do that? Just come with an idea tomorrow? Sounds good. And if you
Okay.
don't, there's no problem. But
yeah,
whatever was going to work
sounds
for you
good.
guys.
Thank you, Dr. Luis.
Thank
Thank you,
you.
doctor.
Thank
Bye-bye.
you. Bye-bye.
Thank you.
Have a
Thank
good
Thank you
you.
very
night.
much. Have a great
Bye.
night.
You too, Muriel.
All right, bye-bye.
Bye-bye.
I cannot believe it.